Hello, and welcome to the part number 5 of course on creating procedural subway tunnel in Houdini. Today we will focus on shading, but before that we need to create some additional attributes in subs and make some slight adjustments in the LOPs network. And speaking of that, let's create a camera. I will set my viewport to this camera. I have lock enabled, so that way I will be able to just navigate my camera in some way. I can change orientation of my camera and I can set my focal length to something smaller. In this case, to have more like a long corridor feeling here, but of course it depends on the particular setup you're about to do. And probably I will rotate it slightly. Let's press enter while this camera is selected and let's slightly rotate it to something like this to have some additional space to observe our textures. And also I will create karma render settings node. And one thing I'm interested in right now is to set the denoiser. It's inside image output and filter tabs. And I will choose NVIDIA Optics denoiser. In my case, it's working fine. So that way we will be able to get some kind of finalized image slightly earlier than if we render something without any denoising. So that will help us a little bit. And one little trick, while we in LOPs and LOPs network that has dynamic connection to subs, and it will evaluate the scene graph tree on each change in our subs until this one is visible, as well as this one, because it needs like a constant access to USD stage. When you have your subs and LOPs working in conjunction and dynamically, and you suddenly notice that you have performance drop while you're working in subs, that's probably because of the fact that you have your scene graph tree evaluating live. So this issue solved just by setting this like a visible tab to something else. In my case, it would be geometry spreadsheet. And just to have this space, I will choose something like Python shell. It doesn't matter actually, just not to see USD specific graphs. Or you can, of course, switch your desktop, but it's not always the best solution. So let's go back to the subs. And here we will need to fix one pretty nasty issue. It's a good thing to constantly check in your indices and your geometry and your attributes. And in my case, what happens, as you can see in our compensate part, in our compensate geometry that we generated before, we have a lot of overlapping patches here. In the indices of these patches, we have like unclear what this digit really is. This happens because we actually just appended the same value wherever amount of times we have in our iterations parameter. So to fix this, we just need to create a switch node and we just need to have this geometry merged in our output only in one iteration, because we just copy this on each iteration. So we can choose, for example, 0 by using the spare input. At spare input, we will reference this node, which contains the information about iteration and number of iteration in this internal loop. So this one is external, just to have this inside of loop properly. And this one is internal, and this one is what we need. So I will create null as an empty input for our switch. And here we will just place this geometry under spare input 0. So repeat begin metadata goes into spare input 0 of my switch node. And in select input, I will type detail -1 as usual iteration. So this means the current iteration number and the 0 component of this particular value, and it shouldn't be equal 0. So when this evaluation is true, we will select 1. So what we're saying is if my iteration number is not 0, then select input number 1 in our switch node. And that way, as you can see right away, we fixed our issue. So let's create some kind of ID attribute for each connected piece. Let's disable the primitive number. We don't need that anymore. And let's just create connectivity attribute. Connectivity, we will be fine with the point attribute. And let's generate random color based on this class attribute. So we will use class point, which is what we need. We will choose random from attribute, and attribute would be the class attribute that we generated. So we have some kind of color here, which will become in handy when we start randomizing our shader for each connected piece of geometry. Next, we need to have some specific UVs on some objects. So let's go to the bottom walls. First of all, I will use it as an example just to start with something. And what I need to do, I need to generate specific UV texture on this. So let's give ourselves a little bit more space. And that's where this setup with object merge comes in handy. You can easily modify your arrangement and not intersect with anything, and you will not screw up a lot of things that could be screwed up otherwise. At this point, after the normal attribute, for example, we can drop down the UV texture node and we will choose texture type called rows and columns. What this mode essentially is doing, it's just converts the prim UV from parametric surface to regular UV coordinates, and it places it in 0 to 1 space in U and V axis. So we don't care much at the moment about any distortion here. If we want to fix that, we can, for example, increase the number of divisions in resample or elsewhere. So as you can see, as I increase this, the distortion is getting less and less, but we again don't care about this at the moment. And also what you can see that this mode, parametric UVs, is actually depends on topology of underlying geometry, which can be advantage and disadvantage in some cases. But in this case, we care only about V axis, so kind of vertical axis. We potentially may benefit from the fact that it's slightly distorted because we don't need to use it as like regular UVs. We will use it like an additional space to generate our shaders. So hopefully this makes sense, and let's work on the orientation of this texture. I want to have it predictable, so I will rotate my texture 90 degrees and I will negate the X scale in this case. So that way on one side I will get correct orientation of my UVs, and clearly I will have V and U, but here I have a problem. As you can see, it's flipped on V axis. And if I, for example, decided to generate some kind of additional wires on this part, I will encounter the nasty issue that my cuts will go kinda in opposite direction. This is because of the fact that we have cutted it from like one single piece of geometry. Of course, we have vertical cuts, but in like this silhouette is actually initially just one connected piece of geometry. So it's actually doing like a logical thing. It's going in this direction. So we need to fix that. Simple and not that safe way to fix this would be to have, for example, each second primitive as a right part and each first primitive as a left part. So like, for example, if we have a group by range, we can potentially just select each second primitive and it would work, but not for all cases, because we actually not sure what we are doing here when we create vertical slices. Maybe for some really serious reason we decided to shuffle our primitive numbers, and that way everything will be destroyed at this point. So let's use something more safe and also learn some useful technique. What I want to do is just, instead of using the vertical slices, so already sliced geometry, I want to reference my initial geometry, so I mean walls without any cuts, and that way I can safely say that if I have even more than one primitive here, each even primitive would be left and each out primitive would be right side. So I will paste it here, and as you can see, 0 and 1, and even if I have more than one curve, so just to illustrate my point, I still will have these parts separated, so 2 and 3 and 0 and 1. This one, 0 and 2 would be left part, and 1 and 3 would be the right part, and I don't have to manage anything more than that. So hopefully that makes sense. Again, now I need to cut it in exactly the same way as I did here. So how do I achieve it? This is where Invoke Compiled block comes in handy. And essentially what it's doing, it's able to call anything that exists inside of compiled block. and can execute it in any input that we have here, or multiple inputs if we need that. So to make this possible, we can, for example, just copy this compiled block and let's disconnect it. So it's kind of exists in vacuum without any inputs. Let's call the input name vertical in this case, and we will place this input name inside of input name field in our Invoke SOP, and let's reference the compile end inside of compiled block field. And that way we actually just executed the same thing inside of this one node, referencing this compiled block here. It's not mandatory to have for each block. What is mandatory is to have compiled block. So it can be any combination of compiled nodes inside of compiled block. So we can just observe the fact that this is exactly the same, which means I can get rid of this whole thing and I have much more manageable setup right now. So I can, for example, make it a bit cleaner, and I can create a block that I will call compiled, for example. And this will act essentially as a simplified digital asset, but inside of your scene. If you don't want to manage this, and if it's not deserving being the separate digital asset, this is like an ideal way to go. But now when we have this Invoke SOP, let's call it vertical, now we can just do the same with this part. So let's say here, and now we have exactly the same cuts as before. So you can actually observe it if I go to the vertical slices, and you can observe that we have exactly the same cuts as in this part. Before we have our vertical cuts, we will invert right part, quote unquote right part, because there is actually no right. Everything is relative, and we will drop down the group by range sub, and we will select each second one, and we will call it left because it's left in this case, and we will reverse this thing, but only not left group. Right now we have mode as a reverse U, and if we look at our UV texture, you see that this is kinda not what we want, but that's okay. We will fix that by using different mode of reverse, which is full reverse. And as you can see in this mode, in this particular case, we have our textures oriented correctly, and we don't have reversed normals. And basically, if we need to create additional set of wires, we can just use carve. And now this would work as expected. So we have these cuts on the same level, which is nice. But what we care about right now is the fact that we have correct UV direction in this one. This would be crucial. And if we look at what we get at the end, if we care, we can change the way we extrude this geometry. We have our sides UVs kind of off, and I will quickly show you that we actually can do it slightly different. So what this particular thing is doing, we don't need that at the moment, and we can use peak node instead of poly extrude node, but let's do it inside of subnetwork just to not pollute our network with this pretty simple operation. And what we can do, we can create for each primitive, and let's go outside of our subnetwork. Because I know I will compile it, I need to have my parameters not referenced between two nodes inside, but I need something that will drive it from outside, and I will call this parameter thickness, or just a thick for now. It would be pretty okay, and I will set range to be from 0 to 1, and I will set it to something like this. I will copy this parameter, and I will reference in the first peak node. I will paste relative reference. I will make it negative, and I will copy it, and I will make it positive. And I will just create merge node. I will skin it, and I need to reverse some of my primitives. Let's look at the indices of these primitives, and of course I need to output the bilinear mesh instead of just the polygons. That way each side would have its own index, and I need to reverse, I think it would be 3 and 0 in this case. So let's use reverse 3 and 0, so 0 and 3. Yeah, it should work. So we have them oriented correctly. And then I need just to have additional merge, create nulls here. So let's change the order, create null here, just to have it more convenient. I will fuse this Now I have geometry basically extruded without any additional unneeded cut in between. And here I can use UV texture sub again, and I will set it again to the rows and columns. And that way I will have some additional UVs. I can actually copy my UV transform. I think I can paste it after my subnetwork. So let's check. Do we have some predictable results? And as you can see here, we have problem. We have reversed patch, and we can easily fix that by reversing this first patch here. And for example, I can add something like poly bevel here, because after I convert it to regular geometry, it won't work with the parametric geometry. So I've converted it, and yeah, let's place UV transform before convert, and now we have poly extrude and things are working correctly. I can go to the exclusions and set ignore flat edges to something like this, and watch what will happen if I have this patch oriented incorrectly. So we no longer have this bevel here, and this can be the issue why you don't get expected poly bevel at some point. So again, we don't care about poly bevel at the moment, but it might come in handy. Probably this one would act a bit better than this one, so that's why we will go here. Now we can get rid of this thing. It was fast and dirty. I'm not saying that this is only and the best way of doing so, because it requires additional work, but it gives you control, but it's not always the solution to all your problems. It's just one way of doing things. Houdini is allowing you to do things in completely different ways, and in the most cases, there is no right answer. You just have to pay some cost for anything. And we probably would need to do the same thing in the upper part, and we will do so, but a little bit later, because I'm really keen to go to the LOPs. So now when we have all our attributes intact, we can start creating shader, and I will isolate the visibility of bottom ball part. So I will create prune node, which will make it just invisible. It won't delete anything. So I will click on this arrow icon here and go to the tunnel, walls and bottom walls and hit OK. And I will set this toggle to prune unselected. So that way we see only thing that we currently working on. Next, let's create material library. We won't be using Karma XPU. We will use principal shader. So we will rely on CPU here, which gives us more freedom in terms of shaders that we can use. And basically we can go as we used to in Mantra. So let's start with adding some attributes that we will need. So first one would be UV coords. Second one, we will use bind. And because we in USD world, our CD attribute got renamed to display color. Display color. That way we will be able to bind this attribute from the USD geometry, and I will set it to either vector or color. So to state explicitly that this attribute is actually vector 3. And the last thing that we will need is just global variables. So kind of like that. Let's check our UV attribute. Let's plug it into base color of our principal shader. Let's call this principal shader walls. And let's go and assign the material to our walls primitive here. So I will apply it, tunnel, walls, apply. And material path would be the walls. So now we have our material assigned. We have the same UV coordinates for each chunk here, which is exactly what we need. We will use only V for the most time, but we also will use the UV as a coordinate. Let's start with creating the leaks, which is more interesting part in this whole setup. So what I need to do, I will just create turbulent noise, and let's plug it right to the base color for now. As you can see, I have exactly the same pattern on each of my chunks. So let's alter this, and we will do so using the display color that we already generated. So let's add random node. Let's plug display color here, and let's generate 3D vector, and let's multiply this display color to something huge. So we will use multiply constant and let's multiply it by 10,000. Let's plug our random to our base color. And if I will add anything additional to input of my random, let's say it would be just a constant, we can later promote it to parameter, and this constant would be something like this. And as you can see, based on the colors that we generated, we now generate the value for random, which is convenient, and we can additionally control the seed of this thing. So then I will multiply my random value to some huge value again, but the difference is before that I've multiplied to get like a different seed from random node, but now I multiply the output of the random node to get big values. So let's multiply it to 10,000 also. And let's add these two positions that we have in turbulent noise. And let's look at what we have right now. So let's go to the base color. And as you can see right now, we have different pattern for each thing here. Next thing I need to do is to control the frequency of this noise. So I will multiply this position after I add, and I will multiply the UV coordinates to some frequency. So I will use multiply, and let's use one of the random outputs here. So I will drop down the vector to float node, and I will feed one of the axes to the frequency. And to control values more, I will add feed range node, and let's set it from 2 to, let's say, 6. Now we have different frequency for each connected piece of geometry. Next thing I need to do is to create the overall character of this pattern. Let's set it to something like 0, 2. And the nice thing about controlling this that way is the fact that now I can set the relation between each axis in the turbulent noise itself, but I can control overall frequency externally. So let's call this one noise frequency. We can color it. For example, anything that frequency related would be yellow. Next thing that we need to do is to utilize the specific feature of turbulent noise node, and this feature is attenuation. It works similar to some kind of mask, but it's actually doing like masking more organically. Let's use the V coordinate that we have generated in our UV coords, and let's feed this to attenuation. And as you can see right away, we have something similar to leaks, but we will adjust it a bit. So we will use feed range again. Let's call it V remap. Let's invert it, and the destination max would be, let's say, 7, and destination mean would be 1 or 2. So that way we have leaks intact. Let's remap the result to make it more contrast, to see better what we have. Probably we can increase the minimum frequency. Let's move it down to not have any intersections. Unfortunately, in WOP-like networks, we don't have anything that acts like a object merge, so we will have to manage its connections more careful than in other networks. So let's make it from 3 to, let's say, 8. So yeah, that's better. We also can alter this V remap based on the vector float, so random source that we have here. So let's add additional feed range, actually 2 of them. And first one would control minimum value. So it would be from 1 to 3, let's say. Let's connect it to V remap node. So let's call it min attenuation and max attenuation, just so we know what's controlling what. And this one would be from 5 to 10. And that way we have additional layer. And the nice thing that just by controlling this seed, we can get a different results. And this one could actually control our overall randomness in general. Now let's work on underlying pattern. One thing I have noticed that we don't have any reflectivity yet. So to create this underlying pattern, we can just really copy everything to have a separate seed. I also will copy the UV coordinates. It's okay to have it twice. And here I will do the following. So I will create my global seed. I will use the previous value as a global seed, and I will give each of these guys their additional seed. We will be controlling separately the seed for underlying pattern and for leaks in our case. So let's do some random thing here. And in this part, I will disable the attenuation controls. So that means I can get rid of this part, and I will set the frequency to be uniform on my turbulent noise. And I will go and set this to the base color. For now, frequency is kinda off. So let's do something like from 0.5 to 2, for example. I'm not a fan of this stretching in this particular case. So instead of using the UV coordinates as we do right now, because we actually don't need it too much, we will use the position, like the global position. Let's create a null here. Let's call it global position. Let's color it red and use this position instead. So now we need to adjust the frequency still. So it would be something like this. And of course, everyone will recognize the alligator noise pattern. So that's why everything that we will do from this point is to break this initial pattern. So first thing that we can do is to add values to our global position, and it can be, for example, the different noise. I think anti-aliased noise and anti-aliased flow noise would work pretty good here. So I will add this thing. Probably I want to control the frequency of this guy. So probably I will place it lower. Let's try to keep this clear. Also, I can press Shift S to have different connections, which in our case seems to be working not bad. So, and here we can just copy this noise frequency node, and let's use it as not a frequency directly, but as a multiplier for initial position. So now we have control over the noise that will deform our initial noise, and it's slightly different, and we can have more different variations. And the same thing we can do for amplitude. Let's say we will rename this one noise amp. This is definitely too much, so I need it to be between these two values. It's just an example of how much granular control you can get and how much variation you can apply to your patterns. And also I will add some anti-aliased flow noise. I can use the same position, or I can duplicate it again and use the third one. And also here probably on the amplitude, I want to use third one also. So here is noise frequency, but for anti-aliased flow noise. Try to make it less convoluted, and I will set the output of my anti-alias flow noise to be 3D input. Let's change its place, and this one would be less to get a more prominent variation. Probably I will increase the amplitude to break it up even more. So this is kinda initial pattern. It should be based on your references, but what I wanted to show that you can control your noise in pretty sophisticated manner. And let's do some kind of ramp here, ramp parameter. So let's try to choose some kind of interesting colors for our gradient of your choice. I don't care about this too much at the moment. And one little thing that I can also do, so whole this setup that we have created, I think to this point could be collapsed to the subnetwork from turbulence noise. We will need all these things, and let's collapse it to the subnetwork. Let's duplicate it. So now we just have a seed as an input, and we can change it to something different and add some additional constant here to this. And now we have slightly different noise and slightly different values on it. And what we can now do, we can use, for example, maximum blended mode, and we can combine these two noises. They are slightly different, and now we have like a more complex pattern, which looks kind of more believable, but it's up to what you're about to achieve. So we have this ramp, and let's also add some color variation to it. So we will add, let's say, color correction node. And here, the same principle as before. We just use one of the randomly generated values. Let's put it here. Let's add a null, just not to have it much of a intersection. And let's go to the shift for the start. Now we have like completely different color for each, but we will fit range this value to something really, really small. What we can do, we can just copy this value, paste it in the second one, and make it kind of opposite. That way we can decide that we want to offset it in both directions. Let's control the saturation, and saturation should be from 1 to, let's say, 0.5. Let's check. Even less hue variation here, just a touch. And let's control the gamma variation also. So it would be 1, and let's say something like this should work. So now we have variation in hue, in saturation, and in gamma. So this is kind of demo of what you can do. Let's implement and add our leaks. We can use actually color correction node here. And let's fit this to the gamma. It's probably better to copy this node. Let's call it leaks map and leave this for reflectivity later and connect the copied one to the gamma. And in the color correction, we will start with 1. We'll gradually decrease the value. Or we can control value itself. We can make it even more contrasty. All these like extremely low values here. And I will increase the lower amount. Now we have the leaks. Probably I think we can increase the frequency to be something like this, or even more. Let's use something big, like a 25. Yeah, I like this one better. It gives me the better feeling of the scale. We can also, for example, control the saturation. So yeah, kind of like this. Let's work on the reflectivity part. And what I need to do is to connect my leaks map to the reflectivity in the principled shader. So I will remind you, it's just a black and white. And here we have the white. So there would be more reflectivity where the leaks are appearing. I will add additional fit range and it would be reflectivity. Let's go here. For now, we don't have much to reflect, but as you can see, for example, here, you can see that we have this headlight or something like this, and it's showing up in the leak parts more. But also what I want to control is roughness of this whole thing, and it should be inverted. So let's plug it in roof value. Let's call this fit range leaks roof, and we will invert the output. Let's check its color. So roughness is 0 on this part, which is exactly what we need. We don't need much of a contrast here, and actually the same on the leaks reflection. Check it with base color. Base reflection is correct. And the minimum roughness should be not 0, but something more like this. So now we have our roughness. So I can see why it may seem like too much, but essentially what we are doing, We just using the attributes from geometry. We use pretty much one noise. We just control it in slightly different manner. We control its frequency for each connected piece of geometry. We also add some additional noise to the position, and we use attenuation, but it's still one noise, and it's just a combination of different states of this noise. So basically, it's all about keeping the track of your attributes, of your setup in general, and trying to be mindful what's going where. But essentially, it's not that complex. It's just cumbersome, to be honest. But the results, in conjunction with the fact that geometry is procedural and it will update on the fly, it's definitely make it worth the effort. See you in the next video.